You got to have a sense. Anyway, fortunately, a lot of the libraries are all available. The back propagation is available. Say, look, I'm just not going to want to learn. I can't understand calculus. I can't understand linear algebra, let alone go into full block library divergence. Can you give me a library subroutine? All right, lots of them are available. Deep learning frameworks about 3 years ago. These names keep changing. There is still TensorFlow is around. There's a Google product over here. TensorFlow. Keras is some kind of a variation of that. That is available. Students seem to like to program in Keras. And the Facebook guys, they developed this PyTorch, widely used. Some of these are all like Piano was a university that is no longer being used. I don't know any of these are being used. Microsoft and Amazon, these two companies based in Seattle, they seem to work together 3 years ago. They said, okay, let's have our own library for deep learning like TensorFlow, and they called it Gluon. There are other names for it today, NXNet and so on. But all these libraries available. So we not only need calculus, we not only need linear algebra, we need probability theory, we not only need complexity, we need to figure out all these libraries are, and all these libraries are all libraries for Python. So you need some Python coding for all of this. So these are all the things that go into it. And okay, I still have another maybe 10 minutes to wrap up. So deep learning, is a disruptive technology. It's going to disrupt computer science itself. It's going to disrupt society also. Wow, would you say that? Well, how does it disrupt computer science? Today, a software developer writes and maintains layers of tangled code. They're written all this logic they put in with while loops and for loops and tests and so on. Perhaps in the future, it's going to be in the form of a teacher that curates the training data set and analyzes the results, saying, okay, let the program learn all of it does. You don't provide the logic. You're just giving it examples. It is figuring out how to do the logic. The logic is not in the form of logic as we understand it. It's going to be the kind of logic that a neural network understands. Neurons that are firing from one layer to the next. And by looking at that, you can't understand the logic, what's going on, but it is learning, right? So maybe the software developer is more of curating the training data set. What about mathematics? Today in computer science, we've emphasized logic, right? So we're saying if then else and so on, that type of logic, discrete mathematics, those are the emphasis. But the future is looking more like electrical engineering. Probability theory, I guess electrical engineers are quite comfortable with continuous mathematics, probability theory, calculus, linear algebra. Not only that, we also need the computing part, the computational complexity. What does NP hard mean, right? You need to have an understanding, because otherwise, that's why you're using this approximate algorithm. Why are you using Monte Carlo? Because it is NP short P complete. Short P complete is even harder than NP complete. So you have these issues. And in the programming environments, people they've been using C++, Java. Maybe it's going to be more of TensorFlow, PyTorch, so on. Right? In 10 years, or maybe even sooner, most software jobs won't involve programming, but being able to use these mental libraries. And what about hardware? We've been using CPUs. Maybe more of this is going to be GPUs, which are graphics processing units, which do this parallel computation efficiently. That is what is needed. We can also think of this idea I got from a developer who works for Elon Musk in Tesla. And he was saying, he was the software manager for Tesla. He was saying, in my lab, what I put into Tesla cars, we have two types of software. One is software 1.0, which is written by human beings. We refer to it as a classical stack. This code we write using Linux, Apache, MySQL, Python, Perl. So that is all the classical stack. And then he's got, I've got all this software in my lab. All of this goes into the Tesla automobiles. And this is code written by the optimizer. This is the neural network deep learning work. It is all in a user-unfriendly language. You can't make any sense out of it. There are millions of weights in it. No human being was involved in the coding, and this is what a diagram for that looks like: weights and weights and weights and all these connections. And he's got more of so he refers to them as software 1.2 or software 2. Mix of both of these things. And a lot of people have argued since then that, hey, look, in my lab, I also have 1.0 and 2.0, and I think eventually all the 1.0 can be replaced by 2.0. We don't need the conventional human logic. Humans can only think of so many possibilities, whereas this kind of a system can think of all the possibilities and so on. Anyway, it's not very clear whether 1.0 is going to get completely replaced by 2.0, but right now it's a mix of both. So I'm going to purposely conclude, and then we can revisit anything that you might ask me about. So my conclusions are that deep learning is a subject inspired by neurobiology, statistical physics, and distributed computing. The new algorithms that are coming out in deep learning, they're coming out every year or every 6 months. There is something that is outdoing what was there before, because some of the brightest minds are now working in this field. The kind of minds that used to do statistical physics and won the Nobel Prizes in physics are all now working on deep learning and many Turing awards and so on. And they're all inspired by how it might be in the human brain, that just like we saw for neurons and the computation. And there are many other models and so on. And the kind of logic that we need to understand here is what is involved in calculus, what does linear algebra have to tell us about it, and about probability distribution, statistics, and about computational complexity, and about distributed architecture. So these are the areas that we need to put it together. So, and all of this kind of deep learning will disrupt computer science and will disrupt software development. That is just a prediction for the future, but that seems to be the trend. Till COVID came along, maybe we stopped doing all of that. Before that, we were saying this is definitely going to happen, but maybe it's going to happen. Maybe it's going to get even more accelerated because of COVID, right? Because we need to have fewer human beings doing things and more automation needed. So all of this is going to get accelerated, right? So that is my message, that machine learning is not yet